The global aerospace industry is buzzing with an unexpected innovation. The PD-14, a revolutionary engine unveiled by Russia. This is not just a newcomer to the market. It is a bold act of technological assertion and creativity. Designed to compete with Western giants like Pratt & Whitney with their PW1000G and CFM International, with the LEAP, the PD-14 embodies Russia's ambition to position itself as a major player in commercial aviation. After decades of waiting, this engine is making its debut, packed with innovations that propel it to the forefront of modern technology. What makes the PD-14 so special, and why are experts scrutinizing every advancement? Let's dive into its origins, innovations, and potential impact on the aerospace industry to discover if it truly has the power to transform it. The journey of the PD-14 began in the late 1990s, a time when Russia was desperately seeking a successor to the PS-90, a powerful but outdated engine incapable of competing with contemporary Western models. Russian engineers quickly realized they needed a technological leap in performance and efficiency to design a truly competitive engine for the 21st century. Thus, in 1999, Russia embarked on the development of the PD-14, aiming to secure the future of its aviation and achieve technological independence. This ambitious project required a complete overhaul of Russian engine technology, integrating international advancements while staying true to local engineering principles. At the heart of this initiative was the desire to match renowned engines like Pratt & Whitney's PW1000G and CFM's LEAP engines, which dominate the commercial aviation sector. In reality, the PD-14 represents a collective industry effort, mobilizing dozens of design bureaus and manufacturers across Russia to achieve this ambitious challenge. The objective was clear: to create an engine capable of powering the new MC-21 aircraft and meeting modern requirements for energy efficiency, emission reductions, and reliability. Despite initial obstacles and the scale of innovations required, Russian engineers committed to developing an engine capable of transforming the national aerospace landscape. The PD-14 is not merely a technical project. It symbolizes Russia's determination to shape its aviation future in a highly competitive global market. This engine incorporates some of the most advanced technologies ever developed in Russian aviation. Among these is a high-pressure compressor with a compression ratio of 11:1, capable of compressing air to extreme levels, thereby improving efficiency and thrust. The combustion chamber, made from a heat-resistant inner metallic alloy, is equipped with low-emission air atomizers, contributing to better energy efficiency and reduced environmental impact. The cooling system of the PD-14 is equally impressive, utilizing single-crystal alloy turbine blades with ceramic thermal coatings to protect them from the extreme heat generated during combustion. This allows the engine to operate at higher temperatures while preserving its durability, significantly enhancing its performance and longevity. These technological advancements place the PD-14 on par with its Western competitors, promising efficiency gains that could redefine the perception of innovation in the Russian aerospace sector. Comparing the PD-14 to engines like Pratt & Whitney's PW1000G and CFM's LEAP, it becomes clear that Russia aims to create a truly competitive engine. With a baseline thrust of 14 tons and energy efficiency comparable to its Western counterparts, the PD-14 positions itself as a key player in the market. One key to this efficiency lies in the relatively lower turbine inlet temperatures of the PD-14, which are about 60 to 80 degrees Celsius lower than those of similar engines. While this results in a slight reduction in thrust, it also lowers operational costs by decreasing wear and maintenance needs, a major advantage for airlines. With a bypass ratio of 8.5, although slightly lower than that of the LEAP and PW1000G engines, the PD-14 still represents a significant advancement for Russian engine technology. This design choice helps maintain respectable fuel consumption levels while making the engine more compact for the MC-21 aircraft it is intended to power. The PD-14 is also a model of reducing operational costs. The company behind the PD-14, UEC, claims that it offers approximately 2.5 to 3% lower operating costs than its competitors, making it a particularly attractive option for airlines looking to reduce long-term expenses. These features, from energy efficiency to cost-effective design, demonstrate Russia's commitment to building an engine that stands out not only in its domestic market, but also on the global aviation stage. For Russians, the PD-14 represents much more than just an engine. It is a technology that has become the cornerstone of their aerospace industry, stimulating employment and innovation across the country. With thousands of engineers, researchers, and workers involved in its development, the PD-14 has revitalized Russian aerospace manufacturing. The production process has undergone radical modernization, with investments in cutting-edge machinery and the establishment of new manufacturing sites. This restructuring has not only benefited engine production, but has also improved the entire aerospace supply chain, creating jobs and developing skills that will impact other sectors. The PD-14 also marks a strategic turning point in Russia's technological approach. Once reliant on foreign engines and components, Russia sees the PD-14 as a response to this dependency, offering a local alternative to Western engines. By relying on national materials and technologies, the PD-14 reduces the impact of foreign sanctions on its aerospace sector and allows it to maintain control over its supply chain, which is crucial in a context of geopolitical tensions. This autonomy also serves as an economic shield against external shocks. By developing an engine that can be produced and maintained locally, Russia ensures that its aerospace industry remains resilient and competitive, even in the event of disruptions to global supply chains. However, despite the impressive achievements and high expectations surrounding the PD-14, its path is not without challenges. One of the main obstacles remains achieving production volumes and operational readiness. Unlike competitors like Pratt & Whitney and CFM International, Russian manufacturers have yet to reach the same production scale, placing the PD-14 in catch-up mode. Increasing production to meet the needs of the MC-21 program and future Russian aircraft will be essential to ensuring the long-term success of the PD-14. The road ahead is fraught with logistical and technological obstacles, but with the national commitment to the PD-14, Russia is ready to face them head-on. The PD-14 represents a promising foundation for a new generation of Russian engines. Building on its core technology, engineers are already working on improved versions, such as the PD-14M, which is expected to offer increased thrust for larger MC-21 series aircraft. In conclusion, the PD-14 embodies the spirit of Renaissance in Russian aviation, a bold response to the industry's challenges. With unprecedented technological advancements and a daring vision, it has the potential not only to redefine aviation in Russia, but also to mark the beginning of a new era of global competitiveness. The PD-14 could very well become the key to unlocking a bright future for Russian aviation. Stay tuned, as the story of the PD-14 is far from over.